Hi, this is the Skill Builder series video on the basics of using the elimination method when solving systems of linear equations. So first of all, we're going to start off with a couple basic, very basic things that we want to look at. One of them is, I want to see, first of all, if we had the number 6, and I asked you to use one of the four main arithmetic operations, how could you create 0? What could you do with this 6 to create 0? Well, we see that the 6 has no sign in front of it, so that indicates that it's positive. So in order to create 0 using the 6, I would have to subtract 6. Okay, and subtracting 6 there, that forms the 0 pair. Whoops, I didn't circle that very well. Let's undo that and try it again. There we go. That forms the 0 pair. Therefore, 6 minus 6 gives a 0. What about if I had -5? How would I create 0 by using that -5? Well, obviously, because that's a negative, then we'd have to add 5 to create 0. Okay, that forms another 0 pair. Okay, so that's using addition and subtraction to form zeros. Okay, so that's forming zeros. And now what if I wanted to form ones? How would we go about forming ones? Suppose I have a -4. How could I form 1 by using that -4? What operation would I use in conjunction with this -4 to make this -4 into 1? Well, that -4, the only way I can get -4 to that, well, there's a couple ways. We could either divide by -4, and that gives us 1. Or if I had -4, I could multiply by -1/4. Essentially the same thing, but that will also give us 1. Okay, so I'm just going to clean up this 1 a little bit. It looks a little sloppy. There. What if I had 7? What operation do I do with that 7 to create a 1? Well, again, you could do one of the two things that we did earlier. We can either divide by 7, or we could multiply by 1/7. And again, we get 1. Okay, so these things are important because when we solve equations, we need to form zeros and form ones. Okay, so suppose I have this equation, -3x plus 8, and that equals -7. Okay, so I want to isolate for x. I want to isolate the x. I want to solve for x. So in order to do that, I need to get the x by itself. So the first thing I want to do is I want to get the x term by itself. So I want to eliminate this +8. So in order to do that, I have to form a 0 with that +8. Okay, so in order to form 0 out of that by using that +8, I need to subtract 8. And you have to subtract 8 from both sides because it's an equation, it's a balanced equation, so we have to do the same thing to both sides. And here is that 0 pair, that's 0. So now what's remaining on this line? What's remaining in this equation then? Well, that's 0, so then we've got -3x equals, and we add those, -15. Okay, so we've now eliminated the 8, we've eliminated the 8 from the left side. Okay, the idea of elimination is key here. And then from there, I would say, okay, well, now that I've formed a 0, now I want to form 1, and that I want to form 1 by getting that coefficient of x to become 1, because I don't care what negative 3x is equals. I want to know what 1x equals. So in order to form a 1, just like we did on the last page, I'm going to divide both sides by negative 3, because I know that negative 3 divided by negative 3, well, or negative 3 divided into negative 3 just goes one time. And so then we're left with, on the left side, we were just left with 1x. And then when we divide negative 15 by negative 3, I get positive 5. So therefore, by eliminating, we've formed a 0 to eliminate the positive 8. And then we formed a 1 to reduce that negative 3 down to positive 1, the coefficient of 1, which we don't need to write here in front of the x, but I'll just write it just for show here. And that gives us x equals 5. So that's the process of solving for a variable. Okay, forming zeros and then forming ones. Or creating zeros, it doesn't matter. Create 0, and then we create a 1. Okay, so that's the process. That's all you have to do, basically, anytime you're solving an equation. Okay, so now the reason why I'm using this term eliminate is because now we're going to move on to solving a system of equations. Okay, so my system of equations is 7x minus 4y equals negative 7. And the second equation is 5x plus y equals 22. Okay, so you notice in the last example, we had one variable. We had that x. Here we have two variables. We've got x and y in both equations. So you got an equation 1 and equation 2. In order to solve these two equations, these two variables, x and y, we need two equations. Okay, there's no way that if I had this 7x minus 4y equals negative 7, that I could use the same principles that I did in the last example and get values for x and y, to get values for both of them. So suppose I want to eliminate this negative 4y. So I'm going to add 4y to both sides. Okay, because that's what we have to do when we're solving equations. And we're left with 7x equals negative 7 plus 4y. Because negative 7 and positive 4y are not like terms, I can't simplify these at all. So they have to stay the way they are. And then if I then, so that's creating a 0. So I created a 0 here on the left side. Okay, so that follows the rule. So I've eliminated negative 4y here. And now I want to create 1. So I'm going to divide both sides by 7. And so here I'm creating 1 by dividing 7 by 7. And so I'm left with x equals, okay, so that's good. So far, so good. And I'm going to separate the numerator into two fractions here. Oops, that's 7. So I'm just separating the two terms in the numerator into their individual fractions. So I've got x equals negative 1 plus 4 over 7y. Okay, that's all well and good, except that because I don't know the value of y, I can't find what the value of x is. And had we tried to find the value of y first by eliminating 7x, we would find the same sort of idea. We get y equals something, and it would be in terms of x. So by using one single equation, we cannot find the value of two variables. Okay, so that's why we need two equations to find the value of two variables. So here we've got this situation here. We've got 7x minus 4y, and here in the second equation, got 5x plus y. Well, I'm going to use the same principle of elimination. I want to eliminate one of these two variables to make my job easier so I can solve for one of the variables. I want to just be left with one variable and one equation, and then I'll be able to solve for the variable that I'm left with. So if I look at 7x minus 4y, 5x plus y, In order to get a similar coefficient, where one is a positive, one's a negative, just like I had over here with this negative 4y plus 4y, if I wanted to do that with x, I'm going to have to multiply this entire first equation by 5 and this entire second equation, and I would do it by negative, but by 7, so I get the coefficients to be the same, and then I could eliminate the x. But that's, I mean, it's doable, but then you're multiplying 22 by 7, and so the numbers are getting big and kind of getting cumbersome. So what I would choose to do then is, I've got this negative 4y, but here I've just got a positive 1y down in the second equation. So I'm actually choosing to multiply this entire second equation by 4. Okay, and just by distributing. So I'm going to rewrite equation 1 again. So I got 7x minus 4y equals negative 7. And then I just multiply this 4 in. So it's 4 times 5, 4 times 1, and then 4 times 22. And so I end up getting 20x plus 4y equals 88. Okay. And so then I can then just add. I'll just add these two equations together. And we get, when we add this, we get 27x. And here's that zero pair. Negative 4y plus 4y is the zero pair. I've now eliminated one variable from the equation. And then 27 plus, or sorry, negative 7 plus 88, that gives me 81. And then all I have to do is, well, I got 27x equals 81. I want to divide both sides by 27. So here I'm forming a 1 with the 27 over 27. And then that gives me just x equals, and then 81 divided by 27 would be 3. And there we go. So that gives me x equals 3. And so the very first step here when forming that 0, I'm eliminating the y variable. And then that just gives me an equation, 27x equals 81, and that gives me one variable and one equation, and I can easily solve for that, the value of the variable, which I've done by forming the 1 then, by dividing by 27. So now that x equals 3, then all I have to do is just substitute, and I'll substitute it into the equation that will, again, give me the least amount of work. And even though I already used equation 2 before, it doesn't matter because we've done elimination. And so I can just substitute, I'm going to substitute into equation 2 because the coefficient of y is already just 1, so I'll have less work to do in the end. So I'm just going to substitute that 3 in for x. And then I've got 15 plus y equals 22. Subtract 15 from both sides of the equation. And here I've got that 0. There's that 0 pair that you always have to do when you're solving equations. So I'm left with y equals 7. So therefore, the solution for my system of equations is 3, 7. Okay, and that's by using the method of elimination. So thanks for watching, and we'll see you in the next video.